Okay, our next talk is Cypherlock Secrets in Time.
So, as the talk already states, this is an experimental torture session. We'll try to find out how long I have to punch you until you give me your password. Of course, it's not because I'm not that violent a person. I'm actually an IT person, not a violence person. I mostly work in black IT, which is IT projects nobody wants to admit to. No, we don't have that database. No, we don't use that communication system. My main focus is covert communications, and in the last few months, I have started to not just work for corporations, but for journalists and activists, and that is actually what the talk is about. So we have problems, and I had a client several years ago. It was a bank, and they had to send their people overseas for business meetings, and they had to carry sensitive data on their machines. So they were, of course, encrypted. Now, the problem is that several countries that they went to basically asked them to decrypt their laptops. And if they wouldn't do that, they would be held in contempt, basically locked up until they gave up their passwords. Now, our current situation is that in more and more countries, the rulings become that if you don't decrypt, you go to jail. Like in Australia, for example, we're talking about you can go to jail for up to 10 years. In the UK, I think it's 5 years right now. And the only way out of that is if you can actually show that you don't have the passphrase anymore, that you forgot it, or that the volume is destroyed or whatever. Now, this is where the talk comes from originally. Now, sadly, about a week ago, I ran into a discussion with our legal department, which told me you cannot actually talk about the details of the project you did for the client way back then. So I had to implement all the code again. So bear with me, it's not that nice anymore. So what is the issue with giving up your passwords or proving that you don't have it anymore? We don't actually have the ability to intentionally forget something. It's not like, oh, I learn my password, and then I cross the border, I get asked, and then sorry, I forgot it right away. Nobody believes that. And it's actually not psychologically possible without harming yourself in some substantial way. And that actually means that you may yourself never know the secret they're asking for, because you cannot forget it, you may not even know it. And the other thing is you shouldn't ever be in the position that you have shared it with anybody, because that anybody then holds your secret and can give it up. Now, the layman would probably approach the problem like this. You create a random secret that you never learn, you create it blindly, you encrypt it to a third party, and then whenever you have to decrypt your device again, you ask the third party for the decryption of your secret, and then you apply it and use it. Now, there's a problem with that, and that is you have shared your secret. So anybody could go to the third party, take the secret from them, and you're forever doomed. Now, what you really have to do is you have to work on oracles. So an oracle is basically a device or a software or an entity that performs wisdom for you. That is where the term comes from, Greek oracles. You ask the thing something and you get an answer. And what you do there is that the first step in creating a random secret and give it to a third party to decrypt it is actually a decryption oracle, is how we call it. And if you hear about Trent, the trusted third party, that is exactly it. Now, the problem is when you have done that, then anybody could, after asking you for the secret, also go to the oracle and say, hey, I want the secret back from you. And the real reason is that this period of time that you have that you can resist torture is actually relatively short. I'm not really sure how many people here have torture experience, but it takes minutes for most people to say, you know what, fuck it. You know, here's my password. They're only like these really hard-ass looking people, like in the back row there, you know. They look like they can maybe stand up for an hour, you know, but in reality, nobody of us is strong enough to really protect. So you have to do something that we call time lock keys. So time lock key is a key that we can show will only work for a certain period of time. Now, what we are doing now is we encrypt our random secret that we don't know to a key that we can show works only for a certain time. And then we use another key, the oracle key, to protect the message that comes out of that. And time lock keys are something that is, in a way, we're actually using that. I mean, most people actually use that. Because time lock keys are nothing else but ratchet algorithms, like you find in Signal, for example, for perfect forward security, or secrecy in this case. It's an asymmetric ratchet algorithm, which means it creates asymmetric key pairs, which is contrary to what Signal does. And it basically works that you have a start value, and out of that start value, you create a sequence of key pairs. You publish the public part of those key pairs, and you assign a certain time to them. And then you go back in the ratchet, you take the original start value, and then you go through the ratchet again, but now in real time. You don't pre-generate, but you follow the time. And the point with ratchets is that you can actually throw away the state. And you cannot go back in time when the state has been thrown away. So that is what you will have in symmetric and asymmetric ratcheting algorithms. Now, in practice, this looks like this. You need a laptop that you want to travel with. It has a networking partition, basically an operating system with networking on it. And you have the actual partition that you want to protect, the secret partition. And then you need a tool that serves as the oracle for you. Now, the tool is software and hardware. The software that I'm actually releasing today is Cypherlock. And Cypherlock implements all these protocols. And you can basically download it, throw it on a Raspberry Pi that you leave at home, that you put Tor on, and then you can use that as an oracle while you're traveling. Now, even if they force you to say, hey, I want to go back, I want to have the stuff again, because the ratchet keys expire and the state is lost, even you giving up the Raspberry after a while doesn't leak your secrets. And then you have a client program on your traveling laptop that you use to interact with your home Raspberry Pi with Cypherlock daemon. Now, when you're actually traveling then you cross your border with your laptop, it's protected, and if nobody bothers you, you just go to the hotel, you unlock your device, and you're happy to go. However, if you're under distress, if they force you to give up your secrets, you only have to wait, and not very long. It depends on what you specifically configure, but you can configure it for like an hour or two. And after that hour and two, that you basically just have to stall the conversation, your secrets will actually become irrecoverable. There's no way to go back and discover your secrets again. But you can prove that your secrets were valid once. So you give up your passphrase after an hour, and the border agent can verify that it's actually the right passphrase, but it doesn't work anymore. Now, there are a few things when you use the tool, and I'm going to talk about the tool a little bit more in a second, it's of course very stupid if you travel, you have your Cypherlock device at home, and you have your SSH key to that Cypherlock device. So don't put that on the unprotected partition. And the other thing, the tool was originally developed to use Tor as the transport layer. And you actually have to use transport layer security or Tor to securely use it. Now, lots of talk that is relatively unimportant now, how to use it. It's actually trivial because we re-implemented the tool to be used by journalists, which are not necessarily known for being the most tech-savvy persons on the planet. So this is how you set up a Cypherlock server on your Raspberry Pi. You download the software, you just say create, and it gives you a signature key that you have to record, and then you switch it on by surf, and that's it. Everything else is automatic. And then on the client, it's a little bit more complicated. You have the Cypherlock create command, which basically creates those Oracle messages for the future, and you can say for which time frames you want to create them. You need a local passphrase that is only for the Oracle messages. That is the passphrase that you would give up when you're under pressure. And you need a way to deal with the secret. You create a secret and you want to use the secret. Now, we're using shell scripting here. You can try it out yourself if you want to pipe it into Lux, crypt setup, whatever. That is exercise for home, so to speak. But it's relatively simple because on Unix systems you have file descriptors that you can juggle around and be happy with. Now, of course, there are a few more options. So we had the create option already. We had the unlock option to unlock your secret. Then there's a thing that's called extend, which basically means take a secret that is still valid and extend its validity for a longer time. Then you can say from when to when your secret will actually be valid. And then there's like help, which is useful, if you don't memorize everything. And everything else is like configuration where to store stuff. But these are actually all options you ever need. Now, you can actually download all of that from the link down there. And it's written in Go, which actually allows you to run it on several operating systems, and there are pre-compiled versions if you trust them. Otherwise, you compile them yourself. And it's for Linux and specifically for ARM64, which is what Raspberry Pis are using. And if you're like an OpenBSD guy like me, that is pre-compiled as well. Now, and that is actually the main part of the talk. Everything else is practice and questions. So I'd like to thank you all for the attention that you actually had, and I have to do a few shout-outs. I'm legally bound to that. So I'd like to thank Frank Brown, who is actually a co-developer of Cypherlock. I'd like to thank Tatiana, who's actually training the journalists in using that. And I thank Frank Rieger, who's doing the context and use cases. Thank you. Any questions, welcome.
All right, thanks for your talk at first. It was very interesting. I don't have so much background in this kind of operation, so my question might be a little bit naive. We have in cryptography at least ways to hide information, like steganography, or
yes,
if you have a more applied sense, you have the TrueCrypt and hidden volumes. And here you are taking a completely different approach, yes, in which there's actually a proof that a person, maybe a journalist, has had some encrypted data on this device. Yeah. Can you reason about this?
Oh, of course, sure. I can. So the problem is that actually no policeman believes you when you're a target that you don't use encryption. That's number one. So it is naive to think that as a target, banker, journalist, whatever, you can cross the border without them expecting you to have protection. That's number one. Number two is when they look at your systems today, and that happens on all major borders today, is they have devices that they plug into your device that do forensic analysis. So that means they look for tools that are installed. They look for how your inodes are used on your computer. They look, when you have an SSD, for example, they look at the caching refresh rates of certain cells. And that is something they do totally automatically. There are several companies that sell those tools. And that actually means that you cannot hide from them that you're using cryptography, and you cannot hide from them, even that you're using hidden volumes. In reality, it breaks down to they will just claim that you're using a hidden volume when you're using VeraCrypt or TrueCrypt or whatever, and they hold you so long that sooner or later you give it up. That's it. You know, the reality is actually that you cannot hide. And when it comes to steganography, for example, that simply only works for very small messages. And even there, we have statistical artifacts that can be relatively easily detected with most tools. So if you're a target, don't trust it. That's it. It's really better to play open cards and to say, yeah, I am protected, but I cannot actually help you anymore. You know, then the playing field is clear, and you're easier to make a legal case actually, because otherwise they'll just claim, hey, you're hiding stuff from us, and before you don't give it up, you know, you go to jail.
Okay. Hi. I have a question regarding this time expiring keys. So basically, if we go through the use case that you have set up, the Raspberry Pi set up at home, you have your laptop with an encrypted drive, and with this time expiring lock. And let's say that the expiry period is 1 hour. Does that mean that your laptop needs to be in constant connection with the Raspberry Pi box in order to, let's say, keep the, I don't know, key from not expiring or something like that?
Exactly. So basically, the timing enforcement is done on the Raspberry Pi. It's remote. You cannot touch it anymore. You can only talk to it with the protocol. So, and what you have on your machine is basically pre-configured and pre-encrypted messages to that device. And you decrypt those messages and send them to the device, which serves as an oracle and sends back the answer. And that only works while the keys haven't expired yet. So it depends on what you set as the update time. So how long is a single key valid? That's number one. And number two is what you configure. So that is basically your, the granularity of the system is the lifetime of the keys. But there is an infinite number of those keys that are created by the Cypherlock. And it is your client that where you can configure, okay, I want a certain time span in which I want to use that. And that can be much larger than the key value, but it can also be shorter. It's just not that secure when it's shorter, but you can set it to longer as well. And that time frame is the time frame in which you have to communicate back to the device. Hence, you need two partitions, basically. You need a networking partition that allows you to connect to the internet, and you have the secure partition, which you decrypt after you contacted the Cypherlock daemon.
Yeah, and so just to add up to this question, so for example, if you're being stopped at the boarding crossing, so basically you need to disable your PC before you actually got, how to say, before you got questioned, because otherwise it will continue syncing.
No, it's not syncing automatically. Oh. So before you're going to the border, you basically run the command and say, okay, it probably takes like 2 hours until I'm through the border, and I give it another 2 hours security window, you know, if I lose my way or whatever. So you basically set the Cypherlock device to be able to be enabled for the next 4 hours.
Oh, okay.
And then you have 4 hours to disable it again. Afterwards, your secrets will be.
Oh, okay, I get it. Thanks.
Hi. Just one question. You were talking now about keeping the secret, actually. But the content on your drive is encrypted in some program, and it's not affected by this product, actually.
No.
So nobody stops customers to, or police or government, to decrypt those files, content of drive. Am I right?
Well, the thing is really that you have two different uses for cryptography here. So one thing is your full disk encryption or partition encryption, and the other thing is where does that encryption have the key from? And it's the first thing that usually is like a password that you put in. In our case, we replace that with the Cypherlock. So it basically allows you to say, okay, here are my decrypt scripts. You can look at the device, how it's set up, and you cannot decrypt the decryption key anymore. That is your proof. So it's two levels of security. We don't do disk encryption. We just protect the disk encryption key.
Okay, thank you.
Yeah, okay, it's me again, since
Hi.
there are not so many questions here.
No, that is actually why I rushed through the talk, so there's more
Okay,
discussion,
okay. So at first, you're trying to prove that you're unable to decrypt your data, which brings some ideas in my mind. Let's say, how do you prove that there are no other copies of your data? I mean, if you have a Raspberry Pi at home, and you can contact it over Tor, then
Or
it's
not.
somewhat reasonable to assume that you were able to copy compromising pictures or whatsoever on that Raspberry Pi.
Okay, let me go to the slide again. That is that slide.
Yeah, but you have to prove it.
No,
I mean,
you-
this is not a proof that you cannot access your Raspberry Pi using a password.
No, the thing is this. The only thing that the border people have at that moment is your device. And you have to create a reasonable explanation why you cannot decrypt it anymore to stay out of jail. So on your device, you shouldn't have the key to be able to connect to your Raspberry Pi. If that is on there, you're doomed because they will find it.
Yeah, but the initial thing was that you're unable to forget a password. So what's
How
the
many
border-
SSH keys have you memorized?
Well, it really depends on the key size. I mean, 1 or 2, it's probably fair if it's elliptic curve key.
Yeah.
So how can I prove that I don't have the key in my mind?
Well, it's maybe we have to go to how law actually works and how police actually works.
Okay.
So police doesn't come there with hypotheticals like maybe you're super smart, maybe you memorize all your passwords, whatever. But what they go by is what they find on your device, because that is evidence, and they go by their experience. So if we have this case that hundreds of people get stopped that have their full SSH keys memorized, then your argument might become true because then it becomes their experience. But I'm pretty sure that they have never encountered anybody where they could show, hey, you have memorized your SSH key. So in reality, what you're doing is you're making a case. This tool helps you to make a case in a secure manner. And it says, okay, this is this practice that we use. We have this certain best practices. And if we would do anything else, we wouldn't have to use the tool in the first place. And that is how you stay out of jail.
And yeah, 2 other questions. The first is, has it worked in practice?
Yes.
Do you have experience?
Yes.
Okay. And the next one, do you plan to audit your source code, or has it been audited already?
Well, as I said in the beginning, I had this little issue that I was not allowed to release the original source code because our client from back then didn't want it. And they paid for it and they kind of had control over it. So I had to re-implement it again. You can actually look at the code yourself. And there is actually a commercial version that is audited, but this is the open source version. If you want to audit it, go ahead, please.
Okay.
Assuming you're stopped and detained and have all your devices taken away and you're stuck in a room where it's impossible to tell the passage of time, how do you know when you can actually give up the non-working secret?
Yeah. You shouldn't take too long of a time spent for that use case. We're relatively good in counting hours. We really suck in counting days. So don't make it too long. Make a realistic time duration. That's number 1. Number 2 is, in most cases, you have recourse to, it depends on the country, of course, but you have recourse to legal counsel. And one of the questions you are allowed to ask is, what time is it?
Allowed to, but in practice, I'm not so sure about that. But either, okay, let's say you ask for the time, and they take this as a hint that you're waiting for something or hiding something. They could hit you with an obstruction charge, for example.
Yeah. So that is why I said the thing you have to do is use realistic time frames. Don't use days on it. You know, if you know it takes whatever, an hour or two to cross the border, then just make it 4 hours until you have to decrypt. You know, and you can do that in reality, and that is what most of our clients do. They enable that on the airplane. So when they land, they open their laptops, they activate Cypherlock, because you don't need a network connection for the activation. You only need it for unlocking it. So you just, you know, when you land, you pull off your laptop, you say, okay, in the next hour, I want to decrypt, otherwise destroy. And we're pretty good in counting hours. Okay. And their processes actually take longer than that.
Okay, I won't keep poking holes in this, but they could just grab you on the flight and you'll never open your laptop.
Of course. And the thing is, if you fly, or when you have this threat model, the threat hanging over you, you have to have threat modeling. You know, I mean, that is the practice. So if your enemy is let's take a random example, the US government, for example, and you fly there with a US airline, yeah, they can capture you as soon as the doors close in Serbia, you know? If you're flying with a Swiss airline, then they cannot capture you before the doors open in the US. So you have to be conscious of your threat model. And that is true for all security tools. If you're looking for a silver bullet, you're going to die.
Thanks.
Well, I was wondering, can we solve the same problem in a more simple manner? For example, what if I tell the police that I don't have a key and my friend is going to cross the border or send a key over the secure channel when I tell him that I safely crossed the border?
Yeah. There is actually the thing where we tried that out. In reality, it requires that you have this friend that travels. It requires you to actually have somebody at home that you can call whatever. So this works for single people under their own control. You don't need an organization, whatever. So it's a practical means to do it. And it's a means that is relatively good against committing operational security errors. So the whole I call home, and please give me the passphrase to decrypt my PGP key, which holds whatever, and so on, is something that might maybe work for a few tech people that have good friends. In reality, in a company environment or for a journalist, that is actually problematic. They're looking for the easiest use case possible with the least dependencies.
So I've been asking questions because of the backups talk yesterday as well, and here I am. I see a new hammer that can hammer my nails. I'm looking for a system that can auto-expire backups that shouldn't be there anymore. Mm-hmm. So you use a key to basically encrypt the whole thing and you expire things. I just ran the tool. It seems to only support one active Cypherlock.
No, you can have multiple. That is what the server part is for. That is for different Redshift servers. You can have, instead of just having one Raspberry Pi at one location, you can have 10 Raspberry Pis in 10 locations and use them to protect the same secret. And they have this path thing, which is basically telling you where the data goes. And if you take a different path, you have a different Cypherlock.
Perfect. And it also has source code. So that already means that this is a great hammer for my nail. Great. Thank you.
You're welcome. Actually, I never thought about that use case.
Sorry, just one very stupid and very realistic question. What happens if your Raspberry Pi is down? Your ADSL at home is down?
Yeah, that is basically what I mentioned right there, is you can have multiple Cypherlocks that protect the same secret. So you have one Raspberry at home, one at your company, and one at your girlfriend or whatever, and that's it.
That's it. Okay, thank you.
Does anyone else have a question? Okay.
Yay, I made it.